Thank you all for coming. This is a third in a series of lectures, the idea of which is to give an account of learning and doing, such that we can see rationality and belief, desire and action as unified. This lecture is entitled Intelligent Action Without Regress, and I think I'm getting an echo. Is that any better? Okay, good, thanks. And I should remind people that there's also a seminar discussion tomorrow morning at 9 in the Ryle room just across in the Radcliffe Humanities Building for all who are interested and want to explore the questions further. Okay, well, so I've got this project, and thinking about it, it reminded me of a famous remark of Paul Dirac, the famous British theoretical physicist, who was writing about his dissatisfaction with the state of physical thought in England at the time, because he would open up a text or go to a lecture, and there would be all these complicated explanations of an electrodynamic phenomenon in terms of levers and springs and pulleys and water flowing through pipes and so on. And he would say, I thought I was entering the orderly abode of reason, but instead I was entering a factory. And these lectures are a factory, I have to confess. I'm trying to build something. He would probably be pretty disappointed that way, but with any luck, it's going to turn out to be a reason factory, that we get to make something in it that looks like reason and can function well in that role. Okay, remember our starting point was the so-called orthodox belief-desire model of action, and a kind of puzzle about it. According to this model, the so-called neo-Humean version of it at any rate, belief is representational, it's inert, has mind-to-world direction if it's capable of truth or falsity, and cognitive. It therefore is potentially rational. Desire has none of these characteristics. It's just the opposite, in fact. And so it's potentially whatever. But nonetheless, it's thought that we can act rationally. And since desire is what furnishes the goal of a typical action, this puzzles me greatly, because I would think somehow or other the role of the desire in giving the goal of action and making the agent potentially rational has got to be stronger than So you could give up on the belief-desire model. I guess most people have done that, and I probably am making a mistake not to do so. But I thought before giving it up, I would give my shot at trying to rebuild belief and desire in such a way that we could actually make sense of their contribution to our rationality. And I built these states over the last two lectures, desire at the top, belief at the bottom. I'll say a little bit about them just to remind you of where we were. Remember that in both belief and desire, there is an object, the intentional object, but it is mediated by a representation. You desire it under a representation, you believe it under a representation. In that sense, then, your relation to the object is both intentional and mediated, and it makes desiring and belief opaque. That is to say, you might desire something under one description or believe it under one description, but not another. Another feature is that desire and belief contribute to guidance of action under an idea. So the idea is something like this. If you have a favorable representation of a state of affairs under a certain aspect, that is going to regulate in you a kind of focused motivational effort to bring about the object of the representation. That was indeed my view, and it turned out Kant's view as well of desire. And in that sense, then, desire functions to regulate your action toward the object of desire and to produce the motivation, the focused motivation to do so. And belief, similarly, orients you toward the object of belief via the representation, but in such a way that you have focused reliance upon the belief, and in that sense, you're willing to act on the belief as well. They also contribute decision weights. One of the key problems in thinking about rational action is if belief is this rational cognitive thing and desire is this thing, how do they ever get together to yield anything that looks like a coherent action tendency? And instead, on this picture, you've got two things that look like the kinds of decision weights that you need in decision theory. You've got a degree of liking or preference or approval, and you've got a degree of confidence or trust, and those are just the things, the kinds of weights that you need for having rational decision theory and also for making the action intelligible in light of what you believe and how much you want the thing. Moreover, they are spontaneously projective states, as I called them. When I have a liking for an object under a representation, that generates in me a kind of affective expectation of the object should I attain it. And that affective expectation then can be compared with the object itself. And that's what's going on here. There is a potential comparison between the representation of what it would be like to have the object and the actual experience of the object. But the same thing is true with belief. When you form a belief, you project a prediction onto the world. You then can see whether your experience indeed conforms to the prediction of the world. And as we saw, that prediction isn't just a simple function of degree of confidence. It is a decision, so to speak, as to what representation you're going to have. And the visual system has to do the same thing. Moreover, these are spontaneously evidence-sensitive states. That is to say, because of this comparison between your expectation and the outcome, you can get feedback, and the effect of that feedback, I argued in both cases, is to change the degree of liking toward the thing, depending upon how much you like the actual outcome, and the degree of confidence that you have in the representation, given whether or not your prediction came out accurately or not. So they have had another feature that I wanted to emphasize. We'll talk a little bit more today, which is that part of what desire has to do is to translate motivation from ends to means. And so the question is, how might it do that? And if indeed, in addition to your positive representation of some object and your favorable representation of attaining it, you have some causal beliefs floating around that you're confident in, then those causal beliefs, because you're confident in them, and the representation, because you're confident in it, can come together to give you a representation of a means in which you're confident. And if you really like the goal, then the affective transfer, which is a common psychological phenomenon, will lead you to like the means as well. Finally, I want to mention there are two kinds of strength of desire, strength of belief. There is the extent to which you are, for example, in the bottom case, confident of a representation. And then there is the degree of expectation you have in something depending upon that representation. So I might be confident of a representation of a die as fair, but my degree of expectation of its coming up 6 would only be 1/6. So there are these two different notions of strength of belief, and similarly two different notions of strength of liking. There's how much you like the object, have a favorable attitude toward it, and then there's how much you actually want, or how much effort you're willing to put into pursuit of the object. And this gives rise to the problems we know familiarly by terms like akrasia or phobia. If you've got a favorable representation of some goal, but maybe it's a distant goal, like keeping yourself on a diet, and you're confronted with a very present salient stimulus of some object that attracts appetitive wanting, then that appetitive wanting can escape the control of this favorable representation and lead to behavior that we call acratic. And this is indeed what seems to happen in addiction. Similarly, you can have a very confident representation that flying is safe. You've read all the statistics. You yourself book flights and want your children to book flights. On the other hand, once you're on the airplane, the door is shut and the thing is rumbling down the way toward the runway, and the wings are kind of sagging and drooping, and there's this funny sound coming from underneath you. Then that stimulus situation produces in you a familiar panic, if you're a nervous flyer, that escapes the control of this representation. So just as there are two degrees and strengths of belief and desire, they can have a general regulative relation, which can also fail in these cases. And then finally, thinking about action, if it's possible, you can imagine these states coordinating with each other. If they can share representational content, as it would seem they could, given their structure, they can therefore share objects that you represent under that content, and that puts you in a relation to the object and a relation to your own action. So it's a de se presentation of the object as both capable of being produced and something that you would like to produce. And so that can give you a tendency to act. Okay, so here's the resulting revisionist belief-desire model. I don't have to talk you through all of this, but these states now, I've tried to argue, are very parallel to each other. They're both representational. They both are effective in action guiding. They both have some degree of mind to world direction of fit. You can assess accuracy of expectation in both cases. There's a representation that regulates an action guiding resource of yours, whether it's attention or motivation or reliance. And in that sense, then, if you believe that these characteristics in the case of belief suffice for rationality, maybe they would suffice for rationality and desire too. And I was pushing, therefore, a kind of broader picture of the idea of mind-to-world direction of fit. It could be truth, but it can also be the directedness of the attitude. Is it picking out the right object, the accuracy of it in terms of its degree, the proportionality of it to the evidence that you've got, the appreciation you've got of the kind of thing it is? Those are all degrees and kinds of mind-to-world fittingness, and it seems that desire can have those as well. Okay. So that's the resulting picture, and that would give us a way of maybe getting to rational action. Now, my claim isn't that these are like Lego blocks. And if you've got two rational Lego blocks, you can put them together any which way, and you'll get a third object, which is rational as well. That can't be right. It's not true with belief. It certainly shouldn't be true with belief and desire. So there have to be specific ways of putting these things together if you're going to take advantage of the rationality of parts in order to get a rational whole. So there are restrictions on how you put them together, but also there are restrictions within them as to how they can be put together, what they will admit of ways of fitting together. And the idea I'm claiming is that when we understand these, we're going to get an entryway into the idea of responsiveness to reasons. So that's our first step today in the direction of responsiveness to reasons. The parts have to be made in such a way that they can combine to yield something rational, and they have to work in such a way that the outcome of combining them is something that we would want to call responsiveness to reasons. Okay, now, is there any kind of a recognizable theory of rationality that I could appeal to that would seem to work in both of these cases, in the case of both belief and desire? And it could be a kind of theory of dynamic rationality of the sort you find in contemporary formal epistemology or rational decision theory. On such views, rationality is not about having a distinctively rational starting point in inquiry or action. Rather, it's a matter of how you respond to experience, how you adapt to experience given your starting point. And this is a generic idea of updating. I'm going to give this very generic characterization of it, which we're going to call star. You start off with a prior expectation that confronts itself with certain experience. You can detect a discrepancy between the expectation and the experience. You can make a posterior adjustment to reduce the discrepancy between the expectation and the experience you've had. Gives you a new prior expectation. That sets you up for a new experience. And so this is a dynamic, continuous process of expectation formation, action on expectation, and revision. And as we saw, that could apply equally well to belief and desire as we characterize them. And it's an important feature of accounts like this, of star-like learning processes or updating processes, that the role that the individual's starting point will, under some very broad assumptions, if given enough experience, varied enough experience, the role of the starting point will diminish with time, and individuals who consistently update in this way will tend to become attuned to what actually happens in their environment in terms of the frequency of events, in terms of the reward values that they estimate from actions. And last time we saw some examples of this kind of attunement in reinforcement learning and in real and simulated foraging. And now as a result, you might say, well, this is only an idealization. It's only under these ideal assumptions that the star processes work like this. The thing is, these assumptions are not so terribly unrealistic that we don't find this kind of learning process throughout the animal world. We find it in animal behavior, in reinforcement learning behavior. We find it in brain systems, in the visual system, in the motor system. We find it in patterns of human infant learning. And increasingly, people who are building inquirers from scratch, not with the particular human crooked timber that we have, but from scratch, where they could start with anything, increasingly they are building artificial intelligence and techniques of scientific investigation using this kind of method. Clumsy and primitive as it might seem, generic as it might seem, it proves to be a very effective way of learning from experience. Okay, now, any such approach has got limitations. Obviously, the starting point imposes limitations. It's going to depend very much upon the quality of experience that you have, the diversity of experience to which you're exposed. And as we'll see in subsequent lectures, these limitations give a very distinctive and powerful role for self-conscious rationality as a way of shaping our beliefs. That is to say, even though this process works very well to do kind of probabilistic learning, there is a distinguished role that self-conscious conceptual reasoning can play that's vital to understanding anything about human culture and society. But it gives us this potential entry point into rationality because it looks like a kind of responsiveness to evidence, or responsiveness to reasons. And this is the dynamic sense of, the broad sense of rationality, rather. It's the sense in which we're not looking at explicitly reasoning processes. Most of what's going on here is implicit. It's not that the rules are being followed by animals by applying rules and knowing rules and so on. So it's rationality in that broad sense, but I don't even want to fight over the word broad or narrow rationality. Let's just call this kind of apt responsiveness to experience intelligence. And I'm using that word on the model of how happy we are to speak of animal intelligence, machine intelligence, artificial intelligence, intelligent systems, and so on. Let's use that notion of intelligence as our entry into the normative realm, the first nose through the door of the tent. Okay, now the point of this is not for me to lower the bar, that I'm going to find something that's an easy goal to attain, like intelligence, rather than something powerful, like narrow rationality. So it's tempting to think that narrow rationality sort of sits at the center of reasoned responsiveness, and everything else just sort of dissipates as you go out toward the edge. But that can't be right. Narrowly rational agents are guided by reasoning and consistency demands. They have consistency in their beliefs, they have means-end consistency, they are judgment sensitive to the judgments that they make and what they think and feel. And if what information they have, what starting point they have, is relatively limited or relatively parochial, there isn't something about that process which guarantees that it's going to be better, that the outcome will indeed not be limited and parochial in just the same way. And it might be that only by being less coherent and consistent could the agent learn what the agent needs to learn to become more intelligent. And if you ask yourself, what do you want in a friend or a colleague or a parent, how high is narrow rationality going to be in your evaluation of this person as a potential epistemic partner compared to their intelligence, their ability to respond adaptively to situations, to pay attention to evidence, to use their knowledge effectively, and so on. So I'm not trying to lower the bar. I'm actually setting a high bar here with this idea of intelligence. And if desire and belief are, as I claimed, regulative processes, how are those to be made intelligent? And so now I'm going to give you a simple little example. Consider this idea of an intelligent thermostat. The old-fashioned thermostat sat on the wall. You set it to a certain temperature, and given enough time, the heating system would come on and go off at just the right moments to make it the case that the room stayed pretty near the temperature that you wanted. But if you wanted to change the temperature for any reason, what would happen is that the heating system would come on, it would reach the temperature that you set it, but it's still got a lot of heat in it, so it would overshoot in the direction of too much heat, but then it would turn itself off and it would start to cool, but because it takes a long time to heat up the heating plant, it would cool so much that it undershoots, and it would overshoot and undershoot, and so it would behave rather in this rather zigzaggy sort of fashion before it could finally settle. If the thermostat could predict that it's reaching the point at which it would need to reach in order to fulfill your demand for temperature, it could modulate the extent to which it's putting out heat and therefore control it in a more effective and efficient way. Similarly, if it could predict your behavior, when you're going to turn up the heat, it could turn up the heat gradually, it could turn it down gradually and save energy and give you more, you'd be happier with the temperature in your room on the whole. And so an intelligent thermostat does that. It uses, in effect, discrepancy-based learning when you turn it up, when you override it, when you turn it down, and it uses that information to model both the physical plant, the heating system, and your own pattern of use. And this fits with a very general thought in control theory, sometimes called the good regulator theorem or the good regulator hypothesis. An intelligent thermostat is a thermostat that learns to model your behavior and the heating system well. The better it can model your behavior in the heating system, the better it can respond efficiently and effectively to the temperature demands that are going to be made of it. And so Conant and Ashby conclude that under very broad conditions, any regulator that is maximally both successful and simple must be isomorphic with the system being regulated. That is, they say, making a model is necessary for a maximally efficient and effective regulator. Now, the mind is a regulator. You've got this organism and you've got the environment, and the mind is regulating the interactions between them. And so the second thing that Conant and Ashby speculated was the mind should therefore make models, because the mind has to model the body, the mind has to model the environment, it has to model the interactions between them, what will be the outcomes of those interactions, or the likely outcomes, how will that do with regard to the needs or goals or whatever of the organism. And so if the mind is indeed a regulator, and if beliefs and desires are indeed regulative states in the ways we've suggested, then they're going to need to build models too. So an intelligent being is a model-building creature. And such models have got some features that should be a little familiar to us. They're projective. They take the existing content of the model and project it forward in time via expectation to guide action, but also to support learning. And they're hierarchical, because often you can get more predictive power by generating a pattern and not just a sequence of events. Such models, given the chance, given the opportunity and resources, will build not just first-order relations, but more general relations, causal relations, spatial relations, and so on. And so model-based control of this kind is actually, like model-based learning, ubiquitous in the natural world. You find it in animals, you find it in the subsystems of the brain, the motor control system, and increasingly artificially intelligent agents, robots, autonomous cars, and so on, use this kind of model-based control. So that's the idea. I'm going to think of intelligent action as action that operates in this way. It's a kind of model-based action where the model is both the frame through which the organism acts, the matrix through which it acts, and the way in which it generates information for learning, and the way in which it interprets the information back to update the model in updating. And so that's my picture of an intelligent agent. And increasingly, that's the picture that we have actually of the intelligent agents that people are trying to build that are going to run around and do things for us in the actual world. Now, all of this is probably producing in some of you a pretty skeptical reaction. Like, really? Animals really build these models? They actually build projective models with causal relations and spatial relations and use those in order to regulate their behavior? Don't they get on very well in their environment through stimulus and control? Well, I have to warn you, we're now leaving the philosophy zone, and I'm going to say a little bit about the state of psychology and neuroscience as I understand it on this very question. So we've already looked at some of the evidence. You recall we looked at the evidence that, for example, macaques in kind of a Pavlovian learning situation can learn accurate representations both of expected value and of risk, that humans in similar situations can acquire the same accurate representations from this kind of a process, and that they can actually now extract from the choices of macaques and other agents, from the gambles that they're willing to take, utility functions that are predictive of their behavior. So this is, in a certain sense, a model. The individual has a utility model of gambles, for example, and if you look at the choices it will make of gambles, it predicts those choices. It seems to be operating with something like a model there. But really, a model? So this is work that's been done on spatial representation. In this case, it's with rats. So you've got a rat, and it's in some box, and it's free to wander around the box. And you've got some electrodes in its hippocampus and its entorhinal cortex. And what people discovered over time is that when the rat is in certain positions in the box, you'll get certain patterns of firing, but then you'll also get this grid-like pattern of firing. That is to say, the rat is not just representing locally the space, it's representing the space on a grid that is non-perspectival. Well, how can it make use of that kind of, why would the rat bother with that kind of information? Well, here's a typical T-maze of the kind they train rats on. The rat gets to start at the bottom. There are usually some false leads along the way that the rat quickly figures out. The intelligent machine is getting ahead of me. The rat quickly figures out are useless until it gets to the meaningful choice point. It can go left or it can go right. And the experimenter rewards it on either side and does so with some degree of reliability, with some kind of reward. And so the question is, what goes on in the hippocampus of these rats? Well, if you let them explore such a maze and reward them and so on, you can indeed find that there's an isomorphic representation, not in the sense that it's the same shape, but in the sense that you can map from these place cell firings to specific locations in the maze. That is built up as the rat explores the maze. It's persistent, it's relatively stimulus independent. And if you watch that same bunch of neurons while the rat is asleep, you'll find that they are still firing, and they're firing in sequential ways. Interestingly enough, the rat seems to be running the maze in its sleep. Does this sound familiar to you? If you look at the way in which the rat is imagining the maze, what you discover is it's actually looking at routes in directions it didn't take, and it's spending more time projecting routes that it did not in areas of the maze that it explored the least. So it's doing a kind of probabilistic learning. It's looking for the most informative bit of the simulation. And in fact, they can begin to develop novel paths. So they will actually construct shortcuts in the maze as they go through. And those shortcuts explain an observation that was made by Lashley, the great experimental psychologist, way back in the 1930s. One day, a rat escaped from the starting box in the maze right here. And instead of going, 8 steps forward and 3 steps sideways and 2 steps back to get to where the food is, it went directly to where the food is. Now, how did it learn to do that? It never took that path. It was never given the chance of taking that path. It had to have a representation of where that food was relative to itself, and darn it, they keep making it walk through this stupid maze in order to get there. So this is why it is that you can solve problems in your sleep, right? The path you didn't actually take during the day, it comes to you while you're asleep, and in the morning you have a solution to a problem that you went to bed with having hit a brick wall. Okay, well, what about if we look at the rat in real time, going through the maze? And so this is a representation, again, of the same area. And we've got a rat that has gone up the central channel of the maze and is sitting now at this choice point. It's supposed to be sitting at the choice point. And what you'll see, if you can see this, is there is activation in the maze representation that has different degrees of strength. And so here it is going first down the right-hand arm of the maze, and you get a certain strength of firing there. It's still sitting at the choice point, hasn't gone anywhere. Then the activation comes back and goes down the left-hand arm of the maze, and this rat has been rewarded more to the right than the left. And so these sweeps continue for a certain amount of time until it builds up to a kind of a boundary condition in which it consistently finds more value on the right side and then it turns right. Now this happens very quickly. This is 1 second down here. So within a second, the rat has, at that choice point, been imaginatively going down both sides of the maze, measuring the expected value that it finds there, and using that model to make its choice within the maze. Okay, now building a brain like this is very expensive. It takes a lot of cells. Developmentally, it's very expensive. Even in a resting state, these mammalian brains use 15 or 20% of all your calories. The level of activity in the brain stays relatively constant, whether you're focused on a task like solving a math problem or just sitting staring into space. So what's the brain doing with all that energy? And a consistent body of evidence suggests that what the brain is doing is the kind of consolidating, organizing, anticipatory tasks, simulating possible actions and outcomes, updating representations and evaluations, establishing new relations among semantically relevant events in its experience. And so in that sense, then, what they're doing is what Google does when you're not searching, which is busily trying to connect all the bits of data in the database in such a way that when it is called upon to search, it will find what you need quickly. And this gives us then a picture of how it is that rats and humans in experiments can engage in something like optimal foraging, how they figure out how to optimally allocate their energy in foraging tasks. And it also suggests how it is that they can do things like the kinds of causal inference that they do, because they've actually got a model of the relations, and it can use that model to infer what should have been expected and from what didn't happen back to what must have been the precursor. Okay, well, the rat brain turns out to have 200 million neurons and 5 times 10 to the 11th synapses. That's a tremendous amount of computing power, which is needed in order to do this kind of simulation. The human brain, by contrast, has 80 to 100 billion neurons and 10 to the 14th or 10 to the 15th synapses. These are rough estimates. It's been estimated that the cycle time of the human brain, since processes can go on simultaneously, is about 80 billion to 15 trillion. That gives you an idea of how accurate these are. 80 billion to 15 trillion action potentials per second. And so in that sense, it's not difficult at all to think that the brain was built with all of this computing power for a very good purpose, and that that very good purpose is what enables you to get on with your day as effectively and efficiently as you can by not simply explicitly acquiring information, relating it to other information. So on the philosopher's model tends to be very explicitated. It can do this stuff implicitly, but it takes a lot of work, and it uses processes like the updating process that we saw. Okay, so let's go back to the stuff we were saying earlier. Intelligence action, I was sort of arguing, was that it's going to be understood, at least here, to be action that is guided by these kinds of causal evaluative models and by learning. And what kinds of mental states would humans have to have in order to engage in that kind of intelligent action? They'd have to have mental states that were representational and content sensitive. They would have to be capable of spontaneously organizing and coordinating the kind of evidence, information needed for thought and action guidance. They would need to be projective, as we saw. They'd have to be responsive to feedback from discrepancy with expectation. Now, that's a lot to ask of mental states, right? That's a lot of complex internal functional structure in mental states. And the question is, have we seen anything like mental states that have these characteristics? And of course, yes, you have. The models that we built of belief and desire have just these characteristics. They're representational, they're content sensitive, they're projective, they learn from experience via discrepancy, they spontaneously regulate the allocation of attention, motivation, expectation, and reliance in action. And so these are the kinds of states which could, if we had them, be the kinds of states that build the kinds of models which, if we had them, could explain why we could engage in this kind of intelligent action. So let's revise the revisionist model. Now, instead of insisting that we've got rational belief and rational desire, let's just say intelligent belief and intelligent desire. That's the result of these kinds of intelligent processes, implicit processes for the most part, and that they could yield something like intelligent action. So that leaves us with a question. Intelligent as these states are, belief and desire, you might still think that it's just, I've just given you a kind of a causal picture. You've got the belief and the desire, and they somehow cause you to act. What would be responsible for putting these components together in such a way as to give your action anything like the structure and unity of intentional action or acting for a reason? Where is the unity or integrity of intention in action if we understand it in these terms? And so what I'm going to do is I'm going to look at an attempt to supply such unity, and then I'm going to see how that attempt fails and suggest what it might tell us about our own possibilities with the belief-desire model. So this is an example used by Thomas Nagel. You've got a toothache. You believe that dentists get rid of toothaches. You desire to be rid of the toothache. And those supposedly jointly cause in you going to the dentist. Now, this is Korsgaard quoting Nagel. As Nagel points out in The Possibility of Altruism, the specifically rational character of going to the dentist to avert an unwanted toothache depends upon how the belief that dentists cure toothaches and the desire to be rid of it are combined. It is certainly not enough to say that they jointly cause the action or that their bare co-presence affects a motive, for a person might be conditioned so that he responds in totally crazy ways to the co-presence of certain beliefs and desires. If the belief and desire operate on the person merely by having a certain causal efficacy when co-present, then rational action is only accidentally or externally different from crazy action, from mad action. For a person to act rationally, she must be motivated by her own recognition of the appropriate conceptual connection between the belief and the desire. So let's try to modify what we had. Now we've got, she desires, get rid of the toothache. She believes going to the dentist will do that. She recognizes that 1 and 2, those two states, have a conceptual connection such that they constitute a reason to go to the dentist. Those now bring it about that she is desirous of going to the dentist, and that then brings it about that she goes to the dentist. But now you could look at this sequence and say, well, that's just a sequence of mental states. You've got a belief and a desire and a recognition and another desire. How are they put together? What combines them such that they aren't just the result of some bizarre conditioning so that they're only accidentally different from a mad action? Well, we could try adding another conceptual relation. You can see how this is going to work. Now she recognizes not only that 1 and 2 have this conceptual connection, but that 1, 2, and 3 have the conceptual structure that's just right, so they constitute a reason to go to the dentist. That jointly causes a desire. That causes going to the dentist. And you can see this could go on for the rest of the evening and a good deal longer. And it doesn't really depend upon seeing these as causal as such. We could think that the recognition constitutes a desire, which then partially constitutes an intention. But we would still need first 1 desire to go to the dentist, then 2 desires, then 3 desires, then 4 desires, and so on. So what this suggests is that the lesson of the Lewis Carroll tortoise and Achilles problem needs to be appreciated more widely. It's often said that his argument shows that we can't think of rules of inference as somehow premises within the inference on pain of regress, and that's right. But the problem is really worse, which is we can't think of applying the rules as operations that intervene explicitly or implicitly between every step in the inference. So the question is, what is an inference if it's not applying rules explicitly or implicitly, agentially, to go from one step to the next? And the answer has to be something like a series of non-inferential steps, not agentially mediated, the taking of which nonetheless constitutes the agent making an inference. And of course, a perfectly rational agent could very easily step back from any particular inference and try to articulate it, take the series of inferential steps by self-consciously invoking and applying rules, but even in doing that, the agent would be non-inferentially taking steps of noticing that the rule applies, invoking the rule, applying it to the premise at hand, and so on. And it doesn't help any to say that these are implicit operations either. So the agent's self-conscious rule following then depends upon inferences carried out by a causal sequence of non-inferential steps, not unified by agential intervention. That seems to be the conclusion. And Wittgenstein suggested that what we need are blind dispositions, immediate transitions in thought without reason, as he put it. Now, I'm not going to try to interpret Wittgenstein here. I think this is a very simple way of looking at his view, but suppose this were all he had to say. You could say, well, that makes it very hard to see how the agent could take herself to be explicitly or implicitly following a line of thought or inferring for a reason, or any kind of acting for a reason, indeed, in this activity of theirs. And it would be hard to see how we differentiate this from the kind of mad activity, the merely conditioned responses that Korsgaard was worried about. So I think the dispositions are going to work only if they aren't really blind. They would have to be responsive to the occurrence and content of certain thoughts. They would have to be responsive to relations of semantic or logical relevance, to the strength of your belief, to the strength of your confidence in the mental process, and so on. So what would be needed are intelligent dispositions. We've already described this notion before. They would have to be alive to the occurrence of certain thoughts. They'd have to be sensitive to the form or content of those thoughts. They would have to have already recognition of relevance and intentionality. They would have to be regulative, non-accidentally guiding what mental transitions one makes in light of the thought's content and context or degrees of confidence. And they would have to be monitoring or feedback, whether the transition results in a thought that seems relevant, plausible, and so on. And so these are all the forms of intelligence that we described earlier. Now, once again, have we seen any examples of mental states that could give us intelligent dispositions of this kind that would enable us to carry out inferences in the sense described? They'd have to be spontaneously projective in thought and action guiding. They'd have to be content sensitive. They'd have to be regulative. They'd have to offer feedback and so on. And once again, we've got our examples. Belief and desire can be like this. Inferring is an action. Inferring is therefore going to have a desire in it just as much as any action does. Belief and desire together can be such as to have the intelligence, the spontaneous thought guiding and projective character, the content sensitivity, the regulative role, and the feedback to make something like inference as a possible activity and an intelligent activity of the agent. So this would then be saying, in effect, that inference is a kind of model-based regulation and control, and that the relations that are relevant to the system in inference or in action generally, the spatial relations, the evaluative relations, the causal relations, the correlative relations, the semantic relations, that these are actually encoded in the model, in the transition matrix of the model structure of the regulator. And that makes it the case that certain inputs will yield certain outputs which are relevant, which depend upon the content, which depend upon the form in which the input is made, which depend upon the degree of confidence in those states, and yield outputs, but they don't require deliberation to do it. It's a continuous process. And that would make it possible to have intelligent inference and perhaps intelligent action. So in closing, what I'm going to do is I'm going to look back at some features of this belief desire model and see the extent to which they could give us the kinds of features that philosophers have noticed are important in intentional action. Well, we've mentioned some of these already. In intentional action, we have something like an intentional object. We have something like a de-se representation of it so that it's relevant to your action. We have acting through the mode of presentation. We have the opacity of the representation so that we can't substitute an equivalent representation. And so we've seen that aspect already of this model. But now take a look at this idea. We can have a spontaneous, they say, coordination of action tendencies around shared intentional content. That is to say, you can have an intentional object of belief and of desire which are such that they can nucleate a shared action tendency just as they could nucleate independent action tendencies before. So in that sense, then, they could give you a representation under which you are acting in a coordinated way in this behavior. So it would be not just intelligent behavior, sensitive behavior in that sense, but it would be intelligent, organized around an idea that gives the intentional object of the behavior. We all have known for quite some time that intention is supposed to guide action under an idea. Well, if you have a belief and a desire, that's what they're built for, this notion of guiding action under an idea, but they have to do it in a couple of ways. They both have to regulate the extent to which you're motivated or focused in pursuing the action, and they have to regulate the extent to which you represent the situation in a way such that what you're doing is appropriate for the realization of that goal. Similarly, intentional behavior is thought to have a desirability characteristic. There's something you're representing favorably that explains and makes intelligible the action. And of course, if you've got a degree of positive affective liking toward the object under a representation that generates for you a positive affective expectation, that is a desirability characteristic. That is a way in which you're addressing the object in a way that represents it as favorable. Well, similarly, we know that the intentional action has to have a satisfaction condition, and the satisfaction condition has to have a continuing role in guiding the action. And so if you've got some degree of confidence in a representation of an action as, let's say, to use Michael Thompson's favorite example, making an omelet, then you'll also have representation of the various component parts of making an omelet, but they won't predict that you've got an omelet until you're at the end of that process. And so in that sense, then, desire for the omelet, which retains that as its goal, as its object, and belief in the making process retain throughout the course of the process a focus on the making of the omelet in order to have the omelet, presumably. And in that sense, then, they coordinate the activity over time, organizing them under this kind of a unified concept. And so that gives you also an answer to what you're doing. Why are you going over to the refrigerator? I thought you were hungry. Well, I'm making an omelet, and there are eggs in the refrigerator, and so that's where I've got to go. Okay, we mentioned before that they contribute decision weights that could make the behavior intelligible, but here's another interesting thing. As affective states, approval liking, positive, favoring, can take a multiplicity of objects, not just propositions. It could take an action or a person or a state of affairs not represented by a proposition, as for example in the presumably may be the case in the animal mind. So they can take a variety of objects, and similarly for relations of confidence or trust. You can count on an individual, trust an individual, count on a procedure, trust your appreciation of a situation, and so on. And so in that sense then, just as we know that intentional action does not always seem to be centered around a proposition, so these states don't seem to be required to be centered around a proposition either. And they afford, in effect, a kind of a common pathway from a representation that may not be propositional to something like organized motivation and organized expectation. So among the various categories that might come in this process would be not just liking, but affection, care, interest, attraction, admiring, disliking, hating, indifference. All of these would have the same kind of characteristic role. And similarly, confidence, trust, assurance, conviction, hunch, certainty, uncertainty, doubt, suspicion, they would all be able to play the belief role. And so in that sense, then, we could have a common pathway toward reliance and toward motivation through the complex capacity of the human affective system to represent all of these different kinds of attitudes. Well, we mentioned that desire and belief are spontaneously projective, and that that's what helps us to learn, because you can then compare the projection with the outcome. They also have another interesting feature by being affective, which is they're non-voluntary. Liking something is not something you can volitionally create. Trusting something or having confidence in it is something you can't volitionally create. Now, is that a problem? Aren't intentions volitions? And the answer is no. You can't, just by will, create an intention. And this is the moral of Gregory Kafka's Toxin Puzzle. Some eccentric millionaire who likes reading action theory makes to you the following deal. He says, if you can intend on Tuesday at midnight to drink this poison Wednesday at 12:01 a.m., then I will give you $1 million. Now, that seems like an easy task, right? All you have to do is intend it. You don't have to do it. Can you intend it? You can try to intend it. You could maybe fool yourself into intending it. But where you can't manufacture the relevant kinds of belief and desire, you can't manufacture the intention either, because you do not want to drink it. And so you can't simply instrumentalize intention any more than you can simply instrumentalize belief or desire. And so we have a picture of how it could be that intention, despite its role in voluntary activity, would be non-volitional in the way that belief and desire are. We also have a sense in which we can account for the idea of mind-to-world direction of fit in these two various states. So recall the problem. Suppose we're trying to explain the difference between belief and a state like imagining something or merely supposing it. Well, if all that we had to go on were whether it's got mind-to-world direction of fit, whether it's capable of truth or falsity, whether it's representational, those states all have these features. So there would be nothing to differentiate the role that supposition or imagining would have in action from belief. If that's all belief we're doing, if that's what were the essence of belief, these states would have that same essence and the same role. What differentiates them is precisely the way in which belief is a committal attitude, an effective attitude of confidence-inducing reliance, and of course that's just what you don't have in the case of supposition or imagination, and that's the sense in which we need to appeal to something beyond the simple model, even in order to explain how belief differs from these other states. And what I claimed in the first two lectures, and maybe this was just another example of my silly overreaching, but I wanted to argue that belief and desire have really a strong claim to be appropriate attitudes, fitting attitudes to have toward their objects. So take the case of belief first. As I said, in supposition or imagining, you could have a representation of some object that's really there, or a representation of some relation that really obtains. That would be true of it, but it wouldn't capture the fact that the thing is real. The imagining doesn't capture the fact that the thing is real. So in that sense, the state of the mind does not correspond to the state of the world. Well, you could say, let's add the thought it's real. But you could imagine the thought of the thing being real, and that still would not correspond to the state of the world, because imagining that something is real is still not taking it to be real in the sense that belief is. So belief then involves trusting that it be real and relying upon it in action, because that's the appropriate response to reality. If you have the evidence and you have the relation to reality, then the appropriate response is not just to imagine or to suppose, but actually to take it on board, to confer confidence upon it, and to rely upon it in action. And in the case of desire, I tried to argue something similar. You could have some favorable representation of something. So the way I like to think about this is a high school football coach, right? And he's trying to talk up the team morale. And he says, look, we all like to win. Everybody likes to win. I could be, in my study, in my easy chair with my beer, watching the Olympics, thinking, boy, I'd really love to win the high jump, right? It's easy to like the idea of winning, but you've got a desire to win. Well, what does it mean to desire to win? It's not just having a positive representation of it of some kind. It's having that representation actually engage your action guiding and motivating capacities in this focused way, so that you're frustrated when you can't make it to practice. You look forward to getting to the weight room. You look toward the games as an opportunity to conquer your opponent. To have a proper appreciation of winning, this coach is telling you, you need not just to have a favorable representation of it, you need to desire it. You've got to value it, and you've got to want it, and you've got to want it because of the way you value it. And that's the sense in which we think that value actually calls for a response from us that isn't just a positive representation. Okay, so desire and belief, I'm arguing, have this capacity to spontaneously co-coordinate in such a way as to induce behavior that is focused on the object, that represents it in a distinctive way, that controls attention and motivation toward the object in a fashion that is controlled by that representation, that pays attention to whether you actually get there or what you get when you do get there, and that uses that information to spontaneously and dynamically adjust your action tendencies as you go along. And so you might want to say, but wait, this, I still don't see, doesn't some kind of action of an agent have to come in here? And so let me use an example that I used last time. So my child has got a kite, his beloved kite. It's gotten caught in a branch in the tree. I'm the big hero. I'm going to climb up the tree, shinny out on the branch, and rescue the kite. And as I do so, as I'm shinnying out on the branch, which I took to be quite a sturdy branch, I hear this sound. Now, my degree of belief spontaneously changes as a result of that. I didn't have to carry out any inference. But my desire to crawl out on the branch spontaneously changes too. It's not as if I've still got this desire to crawl out on the branch. What about my intention to crawl out on the branch? Is it still there? Do I still intend to crawl out on it? No, I'm actually trying to figure out how to back up on this branch without falling off it. So we can indeed, because these are regulative states, because they're dynamic, because they pay attention to what's going on in the world, they notice new information, see whether it's relevant to the action in question, and adjust the action accordingly. They therefore take up this new opportunity, this new information, and spontaneously adjust not just my belief, but my desire and my action as well. Now, we don't think it's a deficiency in people that their beliefs spontaneously update as a response to information. We think that's a way for them to be intelligent, maybe even rational. So why would it be a deficiency in people, rather than a form of intelligence, and maybe even rationality, to spontaneously update intention in the same way? Thanks.